Welcome to Algeomulus Prep Academy. The lesson for today is one-sided limits of piecewise functions. This is a graph of the piecewise function, which is f of x equals x plus 2, x is less than or equal to 6, and x squared minus 1 as x is greater than 6. In the first part, we are going to find the limit as x approaches 6 from the left side. To do this, we are going to directly substitute 6 into the first equation, because from the left of the function, x is less than or equal to 6 as it approaches the limit. So as we implement direct substitution, we end up with a solution of 8 as x approaches 6 from the left. In the second part of the problem, we are going to find the limit as x approaches 6 from the right side. Once we directly substitute 6 into the second equation, we end up with a solution of 35 as x approaches 6 from the right side. In the third part of this problem, we are going to find the limit as x approaches 6. Now to do this, we are going to compare the limit as x approaches 6 from both sides. So from the previous two problems, we found that as x approaches 6 from the left side, it equals 6, and as x approaches 6 from the right side, this equals 35. And as you can see, 6 does not equal to 35. Therefore, we can conclude as x approaches 6, f of x does not exist.
For the fourth part of number 1, we will find the limit as x approaches 7 on f of x. And just a reminder, f of x is equal to x plus 2 when x is less than or equal to 6, and x squared minus 1 when x is greater than 6. Using the graph we sketched, we can see that at 7, the function is continuous and it approaches 48 from both sides. Just to make sure, let's plug in 7 into the original function. We will use the function that is satisfied by 7, x is greater than 6. This gives us 48, which we saw in the graph. For our last problem, we are going to be finding the limit as x approaches 4 from the positive side of the absolute value of x minus 4 all over x minus 4. First, we need to split this function into two separate piecewise functions. Notice there is no equal sign because that would cause the function to be undefined. By graphing the function, we can see that from the positive side of the graph, it approaches 1. To find the limit, analytically, we need to use the appropriate function. Since we are looking for the right limit, we will use x minus 4 over x minus 4. By substituting in 4, we can see that the limit as x approaches 4 is 1. Now for part B of number 2, we will be finding the limit of the previous function, but as x approaches 4 from the negative side. Looking at the graph, we can see that from the negative side, f of x approaches negative 1. Analytically, we can plug in the value to the appropriate part of the function to find the limit. By doing so, we see that the graph is correct and the limit as x approaches 4 is negative 1.
In order to define the limit at 4, the function has to be approaching the same value from the left and right sides. However, in parts A and B, we learned the left side is equal to negative 1, and the limit from the right side is 1. Thus, the limit from the left and right sides are not equal. Therefore, the limit of f, as x approaches 4, does not exist. Next, let's find the limit of f as x approaches 5. Since x does not equal 4, we can use direct substitution to find the limit. Using direct substitution, we plug 5 in for x and solve it out, getting 1. This matches with our graph from earlier.
Thank you so much for watching our video, and please subscribe to Algeomulus Prep Academy.